Your heart is not a pump made of stone, but a biological spring that is slowly being choked by its own internal scaffolding. Every single second you are alive, your cardiac muscle cells are fighting against a microscopic buildup of molecular glue that seeks to turn your flexible, rhythmic engine into a rigid, inelastic block. The secret to longevity isn't just about keeping your arteries clear or your cholesterol low. It is about maintaining the youthful, snap-back elasticity of the heart muscle itself, immensely complicated by complication numbers. Most people assume that a weakening heart is an inevitable consequence of time, but the reality is that your heart doesn't just get tired, it gets stiff. Have you ever wondered why you feel more winded climbing a flight of stairs now than you did 10 years ago, even if your weight hasn't changed? It is because the left ventricle, the primary chamber responsible for pushing oxygen-rich blood to your entire body, is losing its ability to expand and fill. In the world of longevity science, we call this diastolic stiffness. Imagine your heart as a high-performance athletic shoe. When it is brand new, the foam is responsive and bouncy, absorbing energy and snapping back with every step. But as the years pass, that foam becomes brittle and hard. It doesn't matter how hard you push, the material simply won't give anymore. This is exactly what happens to your cardiac architecture at the cellular level. To understand this, we have to look at the scientific kitchen of your chest. Collagens are the most abundant proteins in your body, acting like the structural beams of a house. In a young heart, these collagen fibers are organized in a loose, elegant lattice that allows the muscle cells to stretch wide and then snap shut like a powerful rubber band. It is a masterpiece of engineering. However, as we age, a process called cross-linking begins to occur. Think of it like a master chef who accidentally adds too much cornstarch to a sauce. The smooth, flowing liquid starts to clump, thicken, and eventually turns into a solid mass that won't move. These crosslinks are caused by metabolic byproducts and oxidative stress that literally staple your collagen fibers together. In a landmark study by Dr. Benjamin Levine and his colleagues in 2018, researchers discovered that this stiffening is so profound that a sedentary 50-year-old's heart can actually look and function like the heart of an 80-year-old in terms of its elasticity. But here is the revelation that changed everything. They found that the heart is remarkably plastic, meaning it can be reshaped and softened even after decades of neglect, provided you apply the right biological stimulus before a specific window of time closes. Isn't it incredible that your heart is waiting for a signal to rebuild its own flexibility? Now, let's dive into the absolute peak of this discovery, because this is where the biology gets truly mind-blowing. The heart's stiffness isn't just about the scaffolding outside the cells, it is happening inside the muscle cells themselves, specifically within a giant protein called titin. Titin is the largest protein in the human body, and it acts as a literal molecular spring within every single heart cell. When your heart fills with blood, titin stretches. When your heart contracts, titin recoils. It is the most efficient energy storage device in nature. But as we age, chemical tags called phosphate groups begin to attach to titin in the wrong places, making the spring heavier and harder to pull. A second study, published by Dr. Naza Hamdani in 2016, demonstrated that chronic inflammation and metabolic dysfunction cause this titin spring to become locked in a stiff state. This is the silent engine of aging. When your heart can't stretch, it can't fill with enough blood. If it can't fill, it can't pump. You start to feel fatigued, your brain gets less oxygen, and your overall vitality begins to plummet because your spring has turned into a tether. But what if I told you that you have a manual override switch for this process? What if you could reach inside your cells and replace those rusted springs with shiny new ones? The difference between an aging, stiff heart and a youthful, pliable one is a phenomenon called ventricular remodeling. The most explosive insight from the Levine study was that high-intensity stimulus can actually melt away those collagen crosslinks and restore the titin spring's elasticity. They took middle-aged adults who had been sedentary for years and put them through a specific protocol. After 2 years, the age of their hearts had regressed by nearly 20 years. Their hearts became larger, more flexible, and more powerful. Can you imagine your heart becoming 20 years younger while the rest of the world thinks aging is a one-way street? So, how do we actually do this? How do we take this complex biology and turn it into a daily reality? It comes down to 3 very specific science-backed strategies that target these pathways directly. The first strategy is the 4x4 interval protocol. This is the exact tool used in the clinical trials to de-stiffen the heart. You perform 4 minutes of high-intensity activity, something that gets your heart rate to about 95% of its peak, followed by 3 minutes of active recovery. You repeat this 4 times. Why does this work? Because it creates a massive stretch on the heart walls. This intense pressure forces the heart to expand to its absolute limit, which signals the body to break down old, stiff collagen and replace it with fresh, elastic fibers. You aren't just exercising, you are physically expanding the cage that has been tightening around your heart. Do this just once a week, and you are providing the biological instruction manual for youth. The second strategy involves managing your molecular glue. Remember those staples I mentioned earlier? Those are often caused by advanced glycation end products, or AGEs. These form when sugar molecules bind to proteins like collagen without an enzyme to guide them. It is like pouring syrup into a clock. Everything gets sticky and stops moving. To prevent this, you must focus on blood sugar stability. When you keep your glucose levels steady, you prevent the browning or caramelization of your heart's internal structures. Adding a tablespoon of vinegar before your largest meal or taking a 10-minute walk immediately after eating can significantly reduce the formation of these stiffening crosslinks. You are effectively keeping the syrup out of your heart's gears. The third strategy is the hydration tension principle. Did you know that your heart's elasticity is deeply dependent on the water content of your fascia and connective tissues? When you are chronically, even mildly dehydrated, your collagen fibers become more brittle and prone to sticking together. Think of a dry sponge versus a wet one. To keep your cardiac springs pliable, you need to ensure that your cells are not just wet, but electrically hydrated. This means consuming minerals like magnesium and potassium alongside your water. Magnesium, in particular, is the relaxation mineral. It helps the muscle cells of the heart to fully release after each beat, ensuring the titin spring can stretch to its full length. Take a moment to just listen to your heart right now. Can you feel that rhythmic thumping in your chest? Before today, you might have thought of it as a simple machine, a pump that just eventually wears out like a car engine. But now, you see the truth. You are carrying a living, breathing, adapting masterpiece. Your heart is a forest of collagen and a symphony of microscopic springs. It isn't failing you. It is responding to the environment you provide for it. When you realize that you have the power to soften your own biology, your relationship with your body changes forever. You are no longer a passive observer of your own decline. You are the architect of your own elasticity. Every time you push your heart to stretch, every time you choose to keep your blood sugar stable, you are sending a signal to your cells that says, stay young, stay flexible, stay strong. The stiffness of age is not a prison sentence. It is a biological state that is waiting for you to change the rules. You can feel the difference in the way you breathe, in the way you move, and in the profound confidence that comes from knowing your internal engine is getting more resilient with every passing day. Go forth with this new understanding of your heart's inner spring and never stop exploring the remarkable ways your body can renew itself. This journey into the cellular mechanics of our own longevity is only just beginning, and there is another hidden process happening right now in your very cells that is even more fascinating than the one we just uncovered. Keep listening to what your biology is telling you and get ready for the next revelation in how we can live longer and stronger.